lecture for chapter 9. So the topic we're going to focus on fit and tolerance. The first thing you need to understand what is tolerance. So tolerance usually we define as allowance of a specific variations in the size and the geometry of the part. So as we know, let's say we manufacture a product, like let's say I want to produce a bottle like this. Let's say my specific length for the height for the bottles is like 30 cm. But as you know, nothing is perfect, especially the part that we manufacture. We cannot manufacture something is 100% similar size as we want. Like let's say I need the bottle to be 30 cm. So maybe the manufacturers, they can give me the length, maybe it's like 30.05 or 30.01 or maybe 30.1 or maybe 29.95. So is the size is acceptable or not? So it will depend. So usually, like for part that have larger tolerance, let's say why we need a tolerance. Let's say we have two components in a part. We need to combine these two parts together. So let's say I have a tolerance of the dimension here, the cylinder part here. If I have a very large tolerance, when I fit these two components together, maybe when I fill in water, because of the large tolerance, the gap between these two components will be very big, then maybe it will cause leaking. So means large tolerance sometimes is not good for the assembly models. But if I need these two components to have very small tolerance, so these two components will be very fit. But is it necessary? Because when we require for higher tolerance, the machining parts, we need to have better machine, then maybe our QC rejection rate will increase. So end up, your cost of your part will be more expensive. Then it's about tolerance. Why tolerance is so important? Okay, the first thing is about assembly. So as we know, a lot of the product, they may have more than one components. So we need to make sure all these parts from assembly are within certain range of value, especially the part they need to make together or they need to join together. So if just now I give you examples, if the part have a very large tolerance, maybe when you fit two components together, the part will be loose. If your tolerance is maybe is too small, then your price of your part will be more expensive. Or if the tolerance is off from the value that you want, maybe the two part cannot join together. Another one, we need to make sure interchangeabilities. What does this mean? Okay, as we know, like you purchase any product, like for example cars. Cars, you have many components. Maybe some of the components, some of the part, when it's spoiled, you need to replace with a new part. And we need to make sure all the parts we produce, they are within certain tolerance range. Because why? If let's say today I have some of the part in my car is spoiled, next day I changed a new part. I need to make sure my new part and the old part need to be same. But as we know, it cannot be 100% same, but at least the dimension is within certain tolerance. So when I replace with the new part, it's look no difference for my car. Okay, for the example I show you here, this is some of the mechanical part that they need very high tolerance, very high accuracy. Like for example, your gear transmissions. Okay, if let's say we have very low tolerance, it may be loose between the gears, so maybe the power transmission will be bad. So it's for your gearbox, maybe the fuel consumptions it will it will influence by the tolerance, and also the durability. If your part have very low tolerance, like gear components, so maybe the wear and tearings issue will happens. Okay, the tolerance also we can link to the different type of machinings. Okay, from the figures shown here, you will see that the dimension of the tolerance difference between machining methods. Like, let's say you will see from here, if die fogging method, like hot extrusions, sand casting. So this process, it may have very high it may have very low tolerance, means the variables of your dimension will be very large. So if you can see from here, if you need a very high tolerance, means your part dimension is very precise. So you will see you need some machining method like polishing, lapping, grinding. So if you need components or part with very high accuracy, high tolerance, so maybe you need more machining methods to control your dimensions accuracy. Then the cost of your part will be more expensive. For tolerance, you must understand for tolerance they must have a set of value where you have a high value for higher limit and a lower limit. Or we also can call it what you have upper deviations or lower deviations. Okay, what does it mean? For example, I can show in the figure here. I have a shaft here. Maybe let's say I have a shaft of size of diameter of 5 cm. If let's say my tolerance is set at 0.05, okay, so what is my upper limit or my high limit? So mean my high limit is allowed to have 0.5. So my low limit is what is the minimum size of the shaft I can accept. So it will be 4.95. So this is mean by high limit and low limit. And what is the tolerance? So the tolerance is the size between the smallest and the biggest limit. So this will be my tolerance. Mean if you produce 5.01, yes, I accept. If you produce 4.98, yes, it's accept, because this is between my tolerance. Okay, what is allowance? From the figure here, you will see for the allowance, especially we have two components, we have a shaft and hole, because we need to fit these two components together. So the allowance will become important. So the allowance you will see is the value difference between the lower limit of the hole and the upper limit of the shaft. So actually the allowance is the distance of the gap between two components. Okay, so and what is the largest clearance? So largest clearance will be the allowance plus the total's the tolerance inside the components and the tolerance outside the components. So you will see from here the total largest clearance. How it measures? It will measure from here. See, you measure from here to here. So this is largest clearance. For a tolerance, usually we have two types of tolerance. One is a unilateral limit tolerance, and another one will be bilateral limit tolerance. Okay, the first one, what is unilateral tolerance? So for unilateral tolerance, usually we just only allow a positive or a negative tolerance. Okay, what does it mean? Positive tolerance means we only allow the manufacturers to have the parts to have a bigger size or smaller size. So for example here, let's say we also give you an example of the shaft. Maybe the size of the shaft here, sorry, should be here. The size is, we need like 25. Maybe we set a tolerance of positive 0.1x and positive 0.1. Means our upper limit will be 25.1x and your lower limit will be 25.1, and then your tolerance will be the value difference between these two. So your tolerance is between 0.08. So in opposite, let's say I set a tolerance, a unilateral tolerance with a negative value, where I have a negative 0.1 and negative 0.2. Means my upper limit, it will be 24.9 if I design my shaft to have original size of 25. Then my lower limit, it will be 24.8. Then your tolerance is the value difference between the upper limit and lower limit. So in this case here, my tolerance is 0.1. Okay, then the other type of the tolerance is the bilateral limit tolerance, where we can allow the tolerance to have a bigger value or smaller value. So like this. So usually for bilateral tolerance, we will see a plus minus symbol here. Okay, what does it mean? If let's say I design a shaft with the size of 25, so my upper limit will be 25.04 and my lower limit will be 24.96, and then my tolerance will be the difference between these two values. Okay, so usually for components, especially for the assembly components, usually we have different components we need to fit together, we need to join together. And then how fit between two components, actually we have different type of fits. We have a clearance fit, transition fit, and interference fit. And for the coming slide, I will explain to you what is the difference between these three types of fit. First, we need to know what is fit. Okay, so for fit, we have three different type of fit. Where one is a clearance fit, transition fit, and interference fit. So let's say I give you an example, like we have a shaft and a hole. So if for clearance fit, the value of the clearance must be a positive value. Means the shaft need to be slightly smaller than the hole. So if slightly better from the hole, your shaft and the hole can easily in and out. So in between the shaft and the hole, they will have a small value of the allowance. So how about transition fit? Okay, if for transition fit and interference fit, the value for the clearance will be negative, because your shaft will have slightly bigger size than the hole. Then for interference fit, the shaft will even larger more than the hole. So, but from here, they must have a distance. Let's say your shaft must have 0.025 to 0.08 smaller than the hole. So you will have a clearance fit. Then for transition fit, you must have 0.01 mm larger than the hole, your shaft. I mean the size of the shaft. Then for this one, even larger size of the shaft than the hole. First one, what is a clearance fit? The clearance fit usually the part we need a kiln fit, where the part that we need to be always remove and install, we need to always remove and install. So we need something with kiln fit, means we can easily just fit it in the shaft. We can easily install to the bearing here. But how are we going to control the kiln fit? I mean, how are we going to tell manufacturers I need this component to have a kiln fit? So this is where the tolerance come in, where we can set a tolerance. So for example, for the shaft, we can set a set of tolerance, and also for the hole, where we can set a unilateral tolerance for the shaft and hole. So the bearing size need to have always have a bigger size than the shaft, and the shaft also need to always smaller than the hole. And how about transition fit? Transition fit, where the part like we need is not always need to remove and install. So, and when we install these two components, maybe we need a little bit of force to push it in. For examples, I can give you examples. Okay, this is the pin or clip. Usually we can find in a car part component, where they join all the car part together. And when you install this kind of clip or pin, you need to have slightly apply some force so you can plug in. Because why? Because the size of the pins is slightly larger than the hole. And how we control this? We also control by giving a manufacturer a set of tolerance. Okay, the next one is the interference fit. Okay, so for the interference fit, usually we apply on the part. Usually after we install, we will be never to take it out, or we very rare we will take it out. Okay, for examples, if you check on machine components, usually you can see bearing and shaft. And like this kind of machining components, usually we need an interference fit, where we need a very larger force to install the bearing and the shaft, and it will be very tight. Because why? We need an interference fit, because this machining component, it will subject to vibrations. If we have a very big gap between these two parts, it may easily lose and it will fail. So how we control the fit? We actually control by using tolerance. For a tolerance and fit, is not only we set a value like a unilateral limit or a bilateral limit, but actually from industry they have a set of standard system to follow. Like for example, for British standards, they have a British standard. For German, they have German standards. International standard, they will have a ISO standards. Okay, all these standards, they will have tables to refer, where they have a system. So the way they list out the limits, they use alphabet. They will put the alphabet and the figures to set the tolerance for the shaft and the hole. So it's more easy. If we can refer to the tables, then you can set what kind of fit you need. Then from there, from the drawing, in your drawing, engineering drawing, you can put the alphabets and the value for the fit. So later I will explain for this. ISO system, how they put a tolerance for a limit and fit for shaft and bearing system. So usually they will put alphabet. So for shaft, they will put lowercase alphabet, and for whole system, they will put uppercase alphabet. And usually The H alphabet is usually is a basic size for the shaft and the hole, and the alphabets after H usually refers to the value they allow to have a maximum limit of tolerance for the shaft, but for the hole it will be opposite. The alphabet after H, like after H, K and P, then you will find out the hole need to have a minimum limit for the tolerance. Okay, then for ISO system also, okay, usually H we are refer to the basic dimension or the original dimensions of the shaft or the bearing. That if the alphabet is before H, like A to G, for the shaft system means the shaft must have a lower limit of the tolerance. They are allowed to have a smaller size of the shaft. And for the hole, it will be opposite. If the alphabet is A to G, means the hole can have a smaller size of the hole. They are allowed to have a maximum limit of the hole. This is the examples for the hole and shaft, how we set the ISO limit and fit for the shaft and hole. So for example, for the hole, okay, you will see a value here, and the shaft also we have a value. So this is the basic size, I mean the size that we design. And the limit we're going to set like this, for example for hole. So we will have like H8. So you will see from here, for the hole we're going to use an uppercase alphabet. For the shaft we're going to have a lowercase alphabet. And the limit here, we will have a value 8 and 7. Okay, this value is to indicate what is the maximum and minimum limit for the shaft, for the hole. And for this one, they have a tables to follow. They have a standard reference to follow. And when they want to insert information for the fit for this system, they will write like this: what is the basic size and what is the tolerance for the hole, and slash, and write what is the tolerance for the shaft. For the ISO system, actually you can set the limit for the hole or the shaft system according to these figures. Okay, from here you can see here, okay, it depends on what kind of fit you need. Like here you have clearance fit, transition fit, and interference fit. And then here will be the tolerance for the hole. If you are using the home basic system, so what you need to do is you just need to check on what type of the hole tolerance you're going to use and what kind of fit you need to achieve. Then for the shaft, you just need to pair. You need to find what kind of fit you need, then you just pair with the tolerance for the shaft. You just need to focus on the tolerance of the hole. And here is the maximum clearance, means this one. Okay, let's say you need to have a clearance fit for the shaft and hole, so you may need to reverse what is the maximum clearance you need. Maximum clearance means the gap between the hole and the shaft will be biggest or smallest. You can see from here, if you set a different tolerance, then the gap between the hole and shaft will become smaller and smaller and smaller. If you don't want any gap between them, so maybe you can set a torrent of hole torrent with H7s and pair with the shaft torrent of H6, H5 or 6. And from here, you can see from here, if you want to set for transitions and interference fits, then the maximum current no longer exists because there are no gap between the shaft and hole. At the interface region, actually for transitions and interference fit, you will have some overlapping zone happen between hole and shaft. Now in this case here, you may refer to what is the minimal interference or the maximum interference you need. Then based on the maximum or minimal interference you need, you may refer what kind of fit you need. Then you set according to the whole basic system what kind of torrent for the hole you need. Then you look for the pair of the shaft torrents. Okay, then in opposite, you also can do it in opposite way by referring to the shaft basic system, where you only need to find the torrent for the shaft according to what kind of fit you need. So let's say if you need a fit of current fit, then you may look for the alphabet here, and the alphabet with the different torrents, then you may see what kind of current you need. If let's say you need a bigger current, so maybe you can set your shaft at H11s, then automatically you know that you need to pair with the whole torrent of C11s. So the value of maximum and minimum limit for each system, like what is the maximum and minimum value for H11s for the shaft, and what is the maximum and minimum limit for the C11 for the hole, actually we can refer to the tables, and I'm going to show you the table on the next slide. So this is the table. What I means, you can refer to the tables, so you know that what is the maximum and minimum limit for the shaft and the hole that you're going to design. Okay, so let's say, but from these tables, the naming for the fit will be different. It will mention like this: loose running, free running, close running, and sliding. And from here, actually, when they design a shaft and hole, they have a standard basic size to follow. Like you can see from here, they have a size like 40, 50, 60, 80, 100. And from here, if you design your hole, like let's say you design as H11, then your H11 hole, you need to pair with the shaft to have a limit of C11. Then you can check from here. Let's say your basic unit basic size is 50. So by referring to the numbering, the alphabet systems, so where is the size? Where is the maximum and minimum size for the hole and shaft? So this is what I mean by the ISO system. You can refer to the tables to look for the limit of the size. Here is the example of the tables where you can refer to what type of fit you need, and it will suggest what kind of the standard you can follow. Like if you based on the hole basic or shaft basic, if let's say you set the limit based on this system, then here will be the what kind of fit you will have. So this is a table for your reference. Okay, for this video I'm going to show you how we can insert information like tolerance, limit and fit in a drawing using SolidWorks. Okay, so for normal dimensioning, I think from the previous lectures you already know we can insert smart dimensions. Like for example the height for these cylinders, we can insert the height. Okay, let's say if we want to set a tolerance or limit for the height of this 20, so what you can do, you can click on the value of this 20 here. You can look for the tolerance and precision option under the properties managers. Okay, as you know, for tolerance we have bilaterals and unilaterals tolerance. But from SolidWorks here, for these two type of tolerance, we can insert using either bilaterals or limit. I will show you what is the difference between these two. Okay, for bilaterals, if let's say you want to insert a unilateral tolerance, okay, for unilateral tolerance mean the tolerance only allow you to have a tolerance size where is you allowed to have a either largest or smaller size. Okay, larger size mean you allowed to have the height of this 20. You only to have a higher height, mean you only allowed to have a positive tolerance. So maybe you can set like this, 0.05. So this is the positive unilateral tolerance. Okay, if let's say I can show differently, I can show the limit using the limit. If I show using limit, I can set a positive value for the limit here, 0.05. Then you will see the 0.05 will be my upper limit. My lower limit will be 20. So if I set it differently, in opposite way, I can set it here to have a negative limit. Okay, then if you check, if I set under limit here, I make it 0 first. This one becomes 0.3. Then you will see my lower limit is this, and the 20 will become my upper limit. Okay, like some value, maybe we need to have a bilateral tolerance where we need to have a positive and negative tolerance. So let's say I take this as examples. We can insert a bilateral tolerance. So we can have tolerance like maybe 0.05 here, and here we can have a negative tolerance 0.03. So for bilateral tolerance, it will have a positive and negative value like this. So if limit, so you can see the difference. If you put it as limit, then here 0.05 and 0.03. Oh, sorry, I need to change this to limit. If we put limit, it won't show you what is the basic value for these dimensions. It will show you only the what is the the minimum value and the maximum, mean what is the upper limit and the lower limit for these dimensions. Okay, let's say if you have I put it under here. If let's say you have a bilateral limit where your positive and negative value of your tolerance is similar, so you can consider to insert the tolerance as symmetric tolerance in SolidWorks. So here it will show you can insert the value, only one value like this, 0.5. So you will have the value like positive and negative here, plus minus, like this. Okay, then I will show you how we can insert a feed information for the hole. Okay, let's say I have the hole with the basic size of 30. So you can click the 30 here. Similar also, under the tolerance and precision, you can find feed. You can insert feed. Okay, let's say the first thing you need to define what kind of feed you want. Okay, for the SolidWorks, we have current feed, transition feed, and press feed. So as you know, the press feed actually is referring to the interference feed. Okay, but for how you're going to set the feed, you need to base on the chart and the tables that I show in the previous lectures. So according to the chart, let's say I want to set the feed for the hole here. Let's say I need a current feed. Then I can base on the home basic system. I base on the hole. I can look like, let's say if I want to have a current feed, if based on the host basic, I can have H11 until H7. So I look for H11. Maybe I pick H7. If I select H7 as the tolerance for my hole, then you will find out the shaft that allow me to pair is like F6 to H6 only. Okay, then I select, maybe I pair with H6. Then it will show the information like this. So the uppercase alphabet is mean the tolerance for the hole, and the lowercase alphabet is the tolerance for the shaft. Okay, you can show the display style differently. Okay,